Hey everybody, Mr. Kowalchuk this time. We've got our Unit 10 standards here at the beginning of our Unit 10 packet. We got standards 16, 17, and 18, and this unit is going to be all about trigonometry. Trigonometry is going to start out with radicals, and then we're going to move on to the Pythagorean theorem, and then we'll do special triangles, 45, 45, 90-degree triangles, and 30, 60, 90. From there, we're going to move on to sine, cosine, and tangent, which is kind of the beginnings of trigonometry, finding angles and sides, and then we're going to do application problems and using trig ratios, and then solving sides for application problems and angles for application problems. And then finally, with our trig laws, we're going to do side lengths using the law of sines and the law of cosines, and then application problems using the law of sines and application problems using the law of cosines as well. So we're going to work on all of those in this unit. It's going to be a little bit longer unit. We've got about 10 lessons, and should be great. You'll fill out these important notes and dates with your teacher for Unit 10. All right, let's go ahead and jump in. Really excited about this unit. It's got a lot of fun stuff in it. Okay. Standard 16.1 is going to be lesson 1, simplifying and combining radicals. So this is going to be more calculation based for today's lesson as opposed to the geometric stuff that we've been doing in the past. So circle all the examples of radicals below as our warm up. So just try to remember what it is that radicals are in this situation. Go ahead. Right, hopefully you circled the square root of 3 and 3 times the square root of 2. Those are the only 2 radicals that are here in this particular situation. List of numbers, all different types of numbers here. Okay, messing with the so now what we have is our notes, the beginning of notes on radicals. One of the fundamental algebraic tools you'll need in this unit is how to simplify a radical. A radical is any number with this symbol. Go ahead and put that in there, right? We're going to call this our radical symbol. Today, we're going to learn 3 different things. That's going to be the main focus of what we're doing today in this lesson. The first is, of course, how to simplify a radical. The second is multiplying and divide radicals. And the third is something called rationalizing the denominator. Okay. And we'll talk about rationalizing the denominator and all of these things in just a minute here. I'll turn the light off for a second and see if we can't fix this out. The lighting's been a little bit messy here. All right. Okay, so let's go ahead and start with simplifying radicals. So today and in class, we're going to simplify radicals using a process that we've been practicing a little bit called prime factorization. Now, this process deals with breaking down a number in the radical into its prime values. So here we have the square root of 80, and we're going to split this up into different factors. And what we want to do is we want to find prime factors of the square root of 80. Now, if it's something is inside a radical sign like this, we can split it up into factors, but they also have to be inside radical signs. So a prime factor of 80 I know is 2 because it's even. And I can split it up in half. So 2 times 40, and I'm going to circle my prime factors here. Now that branch of the tree is done because it's a prime. 40 can be split up more since it's not prime. So again, we have 2 radicals here. Now I know 40 is even, so I can split that up in half into 2 times 20. Circle that 2 because that's a prime. And then square root of 20 is square root of 2 times square root of 10. Okay, 2 is my prime, 10 is not. 10 splits up again into the square root of 2 times the square root of 5. And 2 is prime, and so is 5. So that one's all done. All right, so now I've got my factor tree. So that was the first step. Build factor tree. Until primes. And that's when the branch ends at a prime, okay? Second step is going to be combine pairs to make a perfect square. I'll show you what I mean by that. Now, I've got pairs of 2's here. So square root of 2 times the square root of 2 is going to come down, and it's going to give me the square root of 4. 2 times 2 is 4. Same thing here. I've got another pair, so I can make another square root of 4. And then my square root of 5 is just by itself. So that's just going to come down. There's no pair with it. All right, now the square root of 4 is equal to 2 times, these are all multiplied by each other, just like all of these, times 2 times the square root of 5. All right, now that's my third step, is to take the square roots. Another way to think about taking is to simplify, right? Square root of 4 is 2. And then fourth, last step, is to multiply the insides and the outsides. And what I mean by insides and outsides is these 2's are outside of the square root symbol, and this 5 is inside the square root symbol. So this is an inside, and these are outsides. So I can only multiply outsides, and I can multiply insides. So 2 times 2 is 4, square root of 5. And that's my final answer, right there. Okay. All right. So next we're asked to simplify the square root of 108. So let's go ahead and tackle that one and see what that's going to look like. Well, my first step is to break down the factor, build my factor tree until I've got my primes, right? So I know 108 is even, so I can break that up into 2 times the square root of 54, circle my primes. 54 is also even, so I can do 2 times the square root of 27, which is half of 54. 2 is prime, square root of 27. That's also going to be square root of 9 times the square root of 3. Okay. Now 9 is not prime, so I can break that up into the square root of 3 and the square root of 3, and those are both prime. So I got my factor tree. Now I take my pairs, square root of 4. Actually, let me not put this down so low. It's going to be the square root of 4. And then 3 and 3 give me the square root of 9. And then I've got my 1, 3 left over. Square root of 4, I take my square root. This is going to be 2. I simplify. Square root of 9 is going to be 3. And then root 3. And I multiply all those together, and I get 6 root 3. The outsides times the insides. That's my final answer. Okay. All right. I'm going to leave that one for you to jump in with. I'm going to start out by bringing the 7 down and then splitting 48 up into root something and root something else, just like we did over here. Okay, now notes on multiplying and dividing radicals on this one here. You can multiply or divide radicals together if they are square roots. So they all have to be the same square root symbol, like this one here, this one here, this one here. If they can all be cube roots, which is like the cubic root where you would have a 3 there, or if they're all the 5th root or whatever it might be, but they all have to have the same number. Right here, they don't have a number there, and that just implies that it's the square root of it. Okay. Now, 2 root 5 times 4 root 2. This is exactly what I was talking about last year, on the last page when I mentioned 2 root 5 and 4 root 2, the outsides and the insides. So what we can do is we can say 2 times 4 times root 5 times root 2. Now we multiply the outsides and the inside. So that's going to give us 8 root 10. And we're done. We're done there. Okay. Now 2 times the square root of 1 over 4. Now what this says is if we have the square root of a fraction, we can take this and we could say 2 times the square root of 1 over the square root of 4. When we're allowed to do that, when we have a fraction that's divided inside of a square root, we can do the top square root and the bottom square root. So that's going to equal, now we take our simplifying, we take our square roots. 2 times 1 over 2, because the square root of 1 is 1 and the square root of 4 is 2. So 2 over 1 is an improper fraction. We can write that out. We multiply, and this gives us 2 over 2 or 1. Okay. So insides multiply together and outsides multiply together as well. Okay. So let's do 1 or 2 of these together, and then you can practice the rest on your own. So 4 root 6 times 2 root 2 is real similar to this one we did up here. Simplify 3 root 3 squared. Now squaring means you multiply something by itself. So that's going to give me 3 root 3 times 3 root 3, which I'm going to reorganize it so my insides are next to each other. 3 times 3 times root 3 times root 3. Cool. And now I can multiply my outsides, which is 9, and my insides, 3 times 3 gives me the square root of 9. Now I know the square root of 9 is equal to 3, so this is also equals 9 times 3, which equals 27. And that's going to be my final answer there. Okay. All right, now let's do some division here. We have 2 over 8 and root 14 over root 2. So now I have my outsides, 2 over 8 times root 14 over 2. So I combine these the opposite of the way that I did it up here where I separated them. It goes both ways if you want to do that. Now this is just a little bit easier because now I can divide these two. 14 divided by 2 is 7. And that gives me 2 over 8 also at the same time. So this becomes 7. So I have root 7. And then 2 over 8 becomes 1/4 when I reduce. So now this equals root 7 over 4. And I'm done. Yay. All right. Let's move on to rationalizing the denominator. Rationalizing the denominator. All right, so in many basic math classes, what we need to do to rationalize the denominator. Now, all we do when we're rationalizing it is we're getting rid of the square root in the bottom of a fraction. And it's a very straightforward process. All we do is we look at the fraction and we say, do we have a radical sign in the bottom? Well, in this case, yeah, we do. We got a radical 5 or a root 5 there, yeah? Cool. So what we need to do is we multiply the numerator and denominator by the square root you need to rationalize. So we've got root 5 here. So we multiply by root 5 on the bottom and root 5 on the top, which this root 5 over root 5 just reduces to 1. So we're not changing the fraction at all. We're just multiplying it by 1 in a different form. So this equals 15 root 5 over inside times inside gives me square root of 25. Square root of 25 is just equal to 5. So now I have 15 root 5 over 5. Now my outsides can reduce. 15 over 5 just becomes equal to 3 root 5. And we're done. Okay. All right, let's do one more together. 1 over root 2. We multiply, we say, what do we have? Do we have a radical on the bottom? Yes, we do. We have to multiply by that exact radical sign, top and bottom. That's all we need to multiply by. So now we have root 2 over insides times insides, root 4. Square root of 4 is equal to 2. So we have root 2 over 2, and we're done. Okay. I can't reduce anything. I don't have any insides on the top and bottom, and I don't have any outsides on the top and bottom. So I'm done. All right, now this one's a little more tricky, a little bit confusing because we have radicals on the top and the bottom. Oh, I'm off the page here. Sorry. I'm off the page here. So this one's a little bit more confusing because we have radical signs on the top and the bottom. Now, what this tells us is to multiply the numerator and denominator by the square root you need to rationalize. Now, which one do we need to rationalize? The one in the numerator. So that's root 3 here. So even though we've got a bunch of numbers up here, and this is 5 root 3, you might think, oh, I've got to multiply by 5 root 3. You actually don't. You just need to multiply by root 3 and root 3. So only the radical sign that shows up in the denominator. That's the only thing you need to multiply by to rationalize. All right. Now, insides times insides. But hold on a second. I'm looking at this here, and I see the square root of 4. Well, what's the square root of 4? The square root of 4 is 2. So I can just simplify this first and save myself some trouble. 2 times 2 divided by 5 root 3 times root 3 over root 3. So I didn't have to multiply that out and get root 12 and then simplify that, right? Because 3 times 4 would give me root 12. Cool, so that helped us out. 2 times 2 is just 4. 4 times root 3, well, that's an outside and an inside, so I can't multiply those two together anymore. Divided by 5 root 3 times root 3. And now we're rationalizing. Root 3 times root 3 is 5 root 9. And then root 9 is just 3. So 4 root 3 divided by 5 times 3. Now I can multiply outsides on the bottom since I have that. 4 root 3 over 15. Now my outsides are 4 and 15, but I can't reduce that at all because they don't have any common factors besides 1. So we're done there. Awesome. Okay, so the rest of this is going to be your opportunity. We've got 8 all the way down through 19. There's a whole bunch of practice on it. So we'll see you tomorrow in class, and hope this was helpful. Bye.